All right, in the lesson for this video, we are going to be talking all about what are called ratios and extended ratios. To start off, we're just going to keep it simple, talk about what are some basic ratio facts. What can we know about ratios, why are they useful, and how are we going to use them in this class? So a ratio is a comparison of two quantities. Typically, those quantities will be, they can be anything. We'll just call them A and B for right now. So some different ways that you can represent a ratio. One way is as a fraction. So you could write A over B. Oops. Try this a little bit better. Here we go. A second way that you can write a ratio is using a colon. So A colon B. And the last way is that you can actually just write it out, A to B. Now, another important fact is that ratios can be simplified. For example, if you had the ratio 4 to 8, you could reduce that. Both are divisible by 4, and say that 4 to 8 is the same as 1 to 2. Okay, so let's take a look at an example in context. So you've got a music store that has 40 trumpets, 38 clarinets, 24 violins, 51 flutes, and 16 trombones. Write each ratio in simplified form. Okay, so we've got trumpets to violins first. So the number of trumpets is 40, so the number of violins is 24. So a couple of different ways that you can write that. Let's start by writing them as a fraction, 40 over 24. And then we can write it using the colon notation, 40 colon 24. Now in this case, 40 and 24 are both divisible by 8. 40 divided by 8 is 5. 24 divided by 8 is 3. So another way, the simplified way to write this ratio, and that'll be what we're looking for, is simplified ratios, is going to be 5 to 3, which you can then also write using a colon 5 colon 3. If you do end up using Desmos scientific calculator, you can actually do that as well. So if we took 40 divided by 24, let me go ahead and type that in real quick here, 40 divided by 24, we're going to get 1.6 repeating. If you tap over here as a fraction, it'll convert it for you to tell you 5 over 3. Really cool feature if you're using Desmos scientific calculator, that they can actually simplify those for you. All right, let's take a look at another example. Flutes to clarinets. So we've got 51 flutes to 38 clarinets. I'll zoom back out. Here's the 38 clarinets. So we would write that as 51 over 38, or as 51 to 38. Okay, so then simplifying it, let's go ahead and type it in and see what we come up with. If we take 51 divided by 38, we get this number 1.34 as a fraction, 51 over 38. So hey, it doesn't simplify, we'll just leave it. Let's move on to the next one, trombones to trumpets. So trombones is 16, to trumpets is 40, so that would be 16 over 40, which you can also write, remember, this way as well. Let's go ahead and simplify it. So if we take 16 divided by 40, both are divisible by 8, so it should end up being 2 over 5. And hey, what do you know? 2 over 5. All right, one more for this example. Violins to total instruments. So number of violins is 24, and then the total number of instruments, I'll save you the work, is 169. So for total, you just had to add up 40 plus 38, 24, 51, and 16. If you don't believe me, check, see if it works. So then we can write that as 24 over 169, or 24 colon 169. Now these are some pretty big numbers. Let's let the calculator do the work for us. So 24 over 169 is that decimal, and as a fraction, hey, say it's 24 over 169. So hey, we're done. Cool. Let's take a look at some more examples which are a little bit more relevant to what we'll be talking about in class. So let's talk about how these can be used along with angles. So write the ratios for angles and side measures for the first problem. We've got the ratio of two complementary angles is 3/7. Find the measure of both angles. As a reminder, complementary angles are two angles whose sum is 90 degrees. In other words, they add to be a right angle. So I'm going to draw in a right angle, and then I'll draw in our two angles. It says that they are 3 to 7. So in that case, we'll just make this one 3, and then we'll make this part down here 7. Now here's the thing. We know that that's the ratio. That's kind of what they are to each other, but we don't know what they are in terms of the actual angles. What we need to also include is a variable, and you can make your variable anything you want. Let's just call it x. So then let's see, we've got 3x plus 7x then has to add up to the entire right angle, so it has to add up to be 90 degrees. And so, okay, let's combine our like terms. That's why we did all that practice with solving. 10x equals 90 degrees. Then we can divide by 10 on each side to get that x is equal to 9 degrees. Cool. So at this point, now we can actually say what the two angles were. Our first angle, we would take 3 multiplied by x, which is 3 multiplied by 9, which is 27 degrees. Our second angle, we were taking 7 multiplied by x, which is 7 multiplied by 9 degrees, which is 63 degrees. And then if you want to check, does 27 plus 63 really add up to be 90? And it does. So that tells us that we probably got the right answer. All right, let's do a similar problem. This time we've got the ratio of two supplementary angles is 4 to 1. Find the measure of both of those angles. Okay, so 4 to 1, and we've got supplementary. So supplementary, as a reminder over here, means that their sum is 180 degrees, meaning that they add up to be basically a straight line, a straight angle. And so in that case, let's go ahead and draw on the rest of this. Here's maybe the line coming out, breaking up our two angles, and we'll call this our larger angle, so this will be 4, and this will be our smaller angle, so this will be 1. So one angle is 4 times larger than the other one. Would be another way to think about it. Let's go ahead and throw in our variable x to figure out what these two angles are, and then we can set up our equation. So our equation for this is going to be that 4x plus 1x is equal to, instead of 90 degrees, this time 180 degrees. And then we can combine our like terms. 4 plus 1 is 5x equals 180 degrees. And then divide each side by 5. Feel free to grab your calculator if you need to. But 180 divided by 5 is 36 degrees. So there's our value for x. Now we just need to go back and figure out what those angles were. So if we take 4 multiplied by x, that would be taking 4 multiplied by 36, and 4 multiplied by 6 is 144. Our second angle was 1 multiplied by x, which is 1 multiplied by 36, and that's just 36 degrees. Once again, if you want to check to make sure it works, just take 144 plus 36, double check to make sure does that actually add up to be 180, and it does, which means we got the right answer. Okay, so that's the kind of simple ratios. Now let's take a look at what are called extended ratios. So an extended ratio is a comparison of 3 or more quantities. When we write extended ratios, they're always going to be written using colons. In other words, we would write that A is to B is to C. So again, extended ratio, 3 or more, we always use colons. Okay, let's take a look at some examples of where these are useful. So the extended ratio of the measure of the angles in a triangle is 4 to 7 to 9. Find the measure of the angles. So we've got some kind of triangle here. Oops, let's try that again. There we go, that looks a little bit better. Cool. So in our triangle, we've got, it says 4 to 7 to 9. So here's maybe the 4, and we'll put the 7 up here, and we'll put the 9 down here. Now, just like we were doing before, we're going to make those all with x. And then just as a reminder, I think it was on the previous page, all of the angles of a triangle have to add up to be 180. I think that was the only one we hadn't used yet. And so what that means is that 4x plus 7x plus 9x has to add up to be 180. Now we can combine our like terms. 4 plus 7 is 11, plus 9 is 20. So now we've got that 20x is equal to 180, and then divide each side by 20 to get that x is equal to 9. So now we just have to go back and find our angles. For the first angle, if we take 4 multiplied by x, that's 4 multiplied by 9. So one of our angles is going to be 36 degrees. For the second angle, we were taking 7 multiplied by x, so that would be 7 multiplied by 9, which is 63 degrees. And lastly, for our final angle, we were taking 9 multiplied by x, that's 9 multiplied by 9, and that ends up being 81 degrees. And then if you wanted to check, you would just have to see, do all of these add up to be 180 degrees? And they do. All right, let's take a look at another one. So the ratio of the measures of angles in a triangle is 11 to 2 to 5. Find the measure of the largest angle. So in this case, we want just the largest angle. We don't have to find all of them, just the largest. Let's again kind of start with our triangle. And we'll set these up. Here would be 11 up top, maybe 2, and then 5. Really doesn't matter where we put them. Let's go ahead and put x with all of those, and then we can set up our equation. So 2x plus 5x plus 11x, remember, has to still add up to be 180 degrees. So we can combine our like terms. 2 plus 5 is 7, plus 11 is 18. So we've got 18x equals 180 degrees. Divide by 18 on each side, and that should get us that x is equal to 10. So then if we want the largest angle, that would have to be the one with the largest number in front of x, so that would be 11. So 11 multiplied by x, which is 11 multiplied by 10, and that ends up being 110 degrees. Okay, let's take a look at the next one. I think we've got 2 more to look at today, and then we'll be done. So the ratio of the measures of the sides of a triangle is 2 to 8 to 9. If the perimeter of the triangle is 76 inches, find the length of each side. Okay, so we have to be careful with how we set this one up. We're still going to start with the triangle. So still start by drawing in that triangle, and then we'll make our measures of the sides 2 to 8 to 9. So that would mean here would be maybe a side that was 2, here's the one that's 8, and here's the one that's 9. Now, just like we would with angles, we're going to go ahead and put a variable after them. Again, we'll just keep using x. That's a pretty common variable to use. But now, instead of adding up to be 180 degrees, the perimeter is going to have to add up to be 76 inches. And so in that case, we would take 2x plus 8x plus 9x has to add to be 76. And so then we'll go ahead and combine our like terms. 2 plus 8 is 10, plus 9 is 19. So now we've got that 19x is equal to 76. And then we can divide each side by 19 to get that x is equal to the number 4. Okay, so then we need to find all of our side lengths. So for our side length, the shortest one, which was 2 multiplied by x, that would become 2 multiplied by 4. So one of our side lengths is 8 inches. Make sure that you include your label. Our second side length was of length 8 multiplied by x. So that would be 8 multiplied by 4. So that would end up being 32 inches. Lastly, we had our side that was a length 9x. That would be 9 multiplied by 4. That would be 36 inches. And then once again, if you wanted to check to make sure you were right, just add those up. Do they really add up to be 76? And the answer is yes, so we got it right. All right, one last one. Here we go. So the ratio of the measures of the sides of a triangle is 10 to 15 to 6. If If the measures of the perimeter of the triangle is 217 meters, find the length of the shortest side. Okay, so again, we're going to set this one up kind of like the last one. We'll start with our triangle. We've got our three sides are 10, 15, and 6. Again, we'll put x with all of those. We'll go ahead and add those up. So 6x plus 10x plus 15x is equal to the perimeter, which was 217 meters. Go ahead and add up your like terms. So 6 plus 10 is 16, plus 15 is 31. So now we've got 31x is equal to 217. And now we can divide each side by 31. And we'll figure out that x is going to be equal to 7. We just want the shortest side for this one, though. So we can kind of skip the other two. The shortest would have to be the one with the smallest number in front of x. So that would be 6x, which would be 6 multiplied by 7, which ends up being 42 meters. All right, that's all I've got for you this time. In the next lesson, we'll be talking about solving proportions. Until then, have a good rest of your day.